Hey guys, Miss Rivera here. So today we are doing lesson number 3, inverse trigonometric functions. And if you recall from class, we use the inverse of trig functions to find angle measurements. So we're going to review that. So for a warm-up, we have our right triangle. And before we get started, since we're going to be using sine, cosine, and tangent, I want us to recall SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so our very first step is to identify our angle of reference and then identify, what's our opposite side, what's our hypotenuse. So directly across from the right angle is our hypotenuse. So 17 is our hype. And then directly across our reference angle is our opposite side. And next to it, or our last side of the triangle, is our adjacent side. Okay. Now, our sine of this reference angle is so is opposite over hypotenuse. So that's 8 over 17. Our cosine is adjacent over hypotenuse. So that's 15 over 17. And lastly, our tangent, 17. Our tangent is, yes, opposite over adjacent. So 8 over 15. Okay, so for our warm-up, it just wanted us to calculate the trig functions. These are the exact trig functions. It is perfectly acceptable to leave them in fraction form. We don't have to lose precision by putting them into decimals in this case. So let's continue and see. All right, so for number 2, it says you would like to find the measure of an angle. So we're going to use the inverse of sine, cosine, and tangent to find the measures of the angle. Fill in the missing ratios below that you would use that allows you to calculate this angle measurement. Then use your calculator to check that you get the same answer. Write the angle measurement in D. So we're going to use the inverse operation of course, the ratios that we got on top. And remember that we are using these same trig functions to find these trig functions, or the inverse of them rather, to find our angle of reference. So we should get the same answer for each one. So our first ratio that we're going to use, well, that's 8 over, and I am going to now, let me just fix my pen so I can write on top of it and see if it lets me. So 8, oh, it does not let me. All right, that's fine. We'll just write with a pen. So 8 over 17, right? All right, our next one, right, we said cosine is going to be 15 over 17. My beautiful handwriting. And then 8 over 15 is our tangent. All right, so this step you cannot do without a calculator. We need to go use a calculator. And so your phones you can use perfect. They work. Remember that if you have an iPhone, you just turn it, you rotate it to the side. Make sure that you have taken that rotation lock off so that it will turn, and then your calculator will allow you to use the inverse functions. I like to use, of course, RT84 should be on your laptops. I believe we did that before we left. But for me, I have to use my personal laptop to make these videos, so I am going to use the Desmos scientific calculator. And see right here, it has the sine, cosine, and tangent. And I believe I can change that by going to function. And so now I can use the inverse. And so the first one, I press sine, and see, has parentheses. So let me go back to our document, and it's sine of 8 over 17. So 8 divided by 17. And I know some of you like to use the math. I think it's the Mathway calculator. That works too, as long as you're using the inverse function. So here, this says that our angle of reference is about 28 degrees. We're going to round it up to the nearest degree, so it's about 28. I am going to write that in my document, right, equals 28 degrees. Right, and here it says round to the nearest degree, so nearest whole degree. Okay, let's do the cosine, the inverse of cosine. So it's 15 over 17 for cosine. And let's clear all. we're going to do the inverse of cosine. Make sure that the -1 is up there. And we said 15 divided by 17, and that better give us 28. And it gives us the same, 28.07248694. And so then I write that again. Remember, we rounded it, so it is still equal to 28 degrees. And lastly, we have the inverse of tan, that is 8 over 15. And that better give us 28 degrees. So the inverse of tan, function, -1, here we go, main, and what do we say? Was it 8 over 15 or 15 something? All right, let's go back. It was 8 over 15. Okay, so 8, go back inside. 8 divided by 15. Look at that. It also gives us 28.07. So our angle of reference is 28 degrees. So it says for D, we're going to write your angle measurement. That's just 28 degrees. Right. Once we evaluated each of these, it all said 28 degrees. Okay, and so that completes numbers 1 and 2. If you continue to the rest of the documents, you're going to find the length of the hypotenuse of the right angle, right? We use Pythagorean theorem, which is just c squared is equal to a squared plus b squared. Find 2 missing angles in the right triangle above. So now you're going to use your inverse functions. Okay, so for number 4, you're using inverse functions. For number 3, you're using that Pythagorean theorem. So c squared equals a squared plus b squared. Okay, here, once you get all the sides, you're going to create your sine, your cosine, and your tangent, just like we did in in the warm-up and in numbers 1 and 2. Just like we use sine, cosine, and tangent, we're going to take their inverse, and that'll give us their angle measurements. Then that brings us to number 5. So we have another right triangle question, and we are going to, let's look at it. It says a worker places the bottom of the ladder 12 feet from the wall and begins to climb. Is the worker safe? So remember, the worker will be safe, right? To use the ladder safely, the angle has to be between the wall and the ladder must be no more than 15. So anything greater than 15 is not a safe work environment, right? An angle that is greater than 15 degrees is not a great work environment. So the ladder maybe will fall. So you're going to use, again, the inverse functions here of whichever trig function is appropriate. And then you're going to make sure you answer that last question, though. Yes or no, is the worker safe? Why or why not? Then we have the rest of them should all be using your inverse functions now. And for some of you, this might be easier if you draw a picture of what's going on here. So we have you're standing 20 feet away from the Empire State Building, which is this much tall. By what angle do you have to tilt your eyes so you can see the top of the Empire State Building, right? So we have a building, we have you, the fancy smancy person over here. Bam! Let's give you a little, maybe it's a little hot. I'll give you a little hat. It's a big hat, right? Woo! Beautiful hat. And so here is the top of the Empire State Building. What would your eye level have to be for you to see the top? Oh, that is a horrible line, but you get the idea, right? And then, so it's still going to create a right triangle here. And they just want to know, basically, what angle will you have to tilt your eyes upward to see the top? A certain time of day is 96 feet. From the trunk, like you have a palm tree that casts a shadow. What is the angle of elevation? Again, you're looking for the angle. So that's another inverse. Find all side measurements in the 3 triangles below. That could be using Pythagorean theorem if you want. Actually, those are special right triangles, just FYI, so you can actually look up special right triangles. And then more finding the angle. If he's running start, leave start, what is the minimum takeoff angle? And then lastly, and 2 more. What is the angle? An isosceles triangle has a base of 16 inches and a height of 14. Label the angles in the triangle. And isosceles, right? That is a word you should know. isosceles. So that should give you an even better idea, because isosceles triangles have to have two same sides, which means they have two same angles. So you can actually do that with just the word of isosceles. Number 13, on a camping trip, you decide to hang your backpack up. Da 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 da. Is your stuff safe? Okay, when you hang it up on a rope, each side of the rope now makes an angle of 15 degrees with the horizontal. Then a bear comes into your camp and tries to get your backpack with the food in it. Staying on his back legs, he reaches 8 feet. You're going to have to see, is he taller than your backpack, or is all your food gone after he eats it? All right, so I'm hoping that this video helped you more or less understand what you have to do for this assignment. Many of you are still on this lesson, and that's perfectly fine. I just want you to know that next week, which would have been our spring break week, is going to be all makeup work. So if you are not up to date, if you are not on lesson 4 yet, you will still have a chance to continue to do that work next week. Okay, so just continue to focus, keep working hard. You guys are doing an awesome job. And I'll see you soon. Let me know if you need anything, okay? And stay well.